In chapter 23, we switched gears looking at experiments now instead of sampling. So when we were talking about experiments, the first thing we looked at is whether the study was an observational study or an experiment. So with observational studies, no treatments are given. Researchers are just simply observing. So typically this happens when you cannot ethically give some sort of treatment, or it's easier just to observe the variables that you're studying. There's two types of observational studies. We have retrospective and prospective. A retrospective observational study is one that uses past data. So I could do a retrospective study on all of you in AP Stats right now. I could go back and look at your scores from third grade and try to see if your third grade score has any impact on your AP score. Prospective study is a study that happens as you are collecting data, so as time progresses you're collecting. So if I was doing a prospective study with this third grade, what I would have to do is go to an elementary school today, pick a group of third graders, record their scores, and then every year I would follow them recording their scores as we progress. Okay, because observational studies are not providing treatments, they do not prove causation. So you can prove that there's some kind of relationship, or you can speculate that there's association, but observational studies do not prove causation. Okay, experiments, on the other hand, is when treatments are given. There's typically multiple groups in an experiment, so there's a control group and then your treatment group. So I'm going to add that control versus treatment. We talked in this unit that the control group is usually given a placebo, so some kind of fake treatment, so they're not sure what group they're in. This placebo could be just like a sugar pill, it could be lots of things, but that placebo is used so that participants or subjects do not know which group they are in. Experiments can be blind, so single blind means that the participants don't know what group they're in, or the people that are analyzing the data don't know what group participants were in, so just one of the groups. Double blind means neither group knows. So the participants don't know what group they are in, treatment versus control, and the people analyzing don't know which group the subject was in. I do want to point out that with double blind, there's still somebody involved that has to know which subject was in each group. It's usually, the experiment designer, someone who is just a researcher. They're not actually the ones analyzing the results, but somebody has to know what group the subjects came from. Otherwise, it's going to be impossible to draw conclusions. Okay, we talked about how to design experiments, and there were three main types of experiments we looked at. The first type is just called a randomized experiment. With this randomized experiment, you would start with your subjects, and the easiest randomized experiment is to just have these subjects split up into two groups. So one group would receive the treatment, and the other group would be your control group, so they are receiving a placebo. Okay, one thing that's really important is that we need to indicate that this alignment of, whether you get the treatment or the control was random. So we usually wrote in here that this was randomly assigned. We want to make sure that subjects are randomly assigned to either receive the treatment or the control. Okay, once you have your subjects in the two groups, we're going to collect and compare data. On the AP exam, if you're asked to design an experiment, they're okay if you make this little diagram here, but you do want to be very specific. So if they tell you the number of subjects, make sure you include that. Instead of just saying collect and compare data, be specific. What kind of variable or what variable are you collecting and comparing? Okay, the next type of experiment is called a blocked experiment. So in this kind of experiment, typically what you'll do is block based on some kind of variable that you think is impacting your study. So before splitting your subjects into the treatment and control groups, they would have been blocked by some other variable. So I might start here with my subjects, but maybe I think that gender is going to play a role in the data, so I'm going to take my subjects and split them into males and females. Okay, this is not randomly assigned because I'm not deciding who's a male and a female. It's a pre-existing variable. I'm just splitting them up into these groups. Now in my male group, I'm going to split up into two groups again, where one group gets the treatment and the other is the control. Females will do the same, so I have treatment and I have a control group. Again, once I have my groups, I am collecting and comparing data. Okay, blocking is nice if you believe that some variable that you're not actually giving or testing as part of the treatment, but some other outside variable is going to impact your study. So in this case, I would be able to see whether my treatment had more of an effect on males versus females, which might be a nice kind of addition onto that study. Okay, and the last type of experiment we looked at is called a matched experiment. Sometimes this is called matched pairs. There's lots of different ways that you could do a matched pair experiment. You could just kind of group people together that are alike. So I would say for this first one, you would have alike or similar. I think I spelled similar wrong. So you would have alike or similar people grouped together. So I might have one group of 18-year-old women. So maybe I have one 18-year-old woman and another 18-year-old woman. They're grouped together. One's going to get the treatment, one's going to get the control. Then I have an 18-year-old man and another 18-year-old guy. Okay, they're grouped together. One gets treatment, one gets control. Okay, another way to do this is to use pairs that just kind of occur in the real world. So you could do like glasses or shoes. So maybe I'm testing some kind of new waterproofing spray. And instead of just like splitting people up into groups, I'm going to take my participants, I'm going to randomly decide which shoe gets the treatment and which shoe gets an old treatment. And so then every person that's walking around would have both. So like, here's my person, here's their shoes. Okay, this guy would have the new spray and then the old spray. This guy, it might be switched. So maybe this is old and this is new. But that would be another example of a matched pair. The matched pair is just happening on one specific subject. Okay, there are four main principles of experiments. The first is that you must have a control group. You always need to have a control group. If you don't have that control, there's no way to make comparisons, which can be a big issue. The second is that you need to make sure that the treatments are randomized. So this random assignment to the treatment group versus the control group is an essential piece of an experiment. Good experiments should be replicated so we can tell, whether this results just happened by chance or did it happen purely because of that treatment. And then not all experiments need to be blocked, but if you think that some other variable is impacting your study, you do want to go ahead and block. Okay, we do want to keep an eye out for lurking variables. It's very possible that we run this experiment and we might have evidence that says our treatment worked. If there is a big lurking variable out there, we want to make sure we're watching that. Perhaps we could design our study using a blocked design to account for that lurking variable. And the big idea with experiments is if we find large differences between the control group and the treatment group, then those differences are said to be statistically significant. To test how significant these things are, we would run a hypothesis test. So oftentimes on the AP exam, what you'll see is the prompt will give you an explanation of the data they're trying to collect. Part A might say for you to design an experiment, and then part B, they might provide you a little bit more information and have you run a hypothesis test based on findings from that experiment.